Well, hello. My name is Matthew Harvey Sanders. I'm the CEO of a company called Longbeard, which is focused on primarily building and scaling Catholic AI. It's my pleasure to be with you all. And my presentation, titled Why It's Too Important a Technology to Ignore, will focus primarily on artificial intelligence and its kind of implications today. And at the end, we'll focus a little bit on specifically Catholic artificial intelligence. So to get the ball rolling here, I thought we'd open up with a quote from Sundar Pichai, who's the current CEO of Google. He says here, "I think AI is probably the most important thing humanity's ever worked on. I think of it as something more profound than electricity or fire." I think this sentiment probably well encapsulates, I think, most of the industry's optimism about artificial intelligence. I think it's hard, considering what we're doing here is basically kind of creating another form of intelligence, to argue that this is not going to have significant impacts on civilization. I think certainly to the tune of electricity or fire, and I think, as Sundar says, perhaps even more so. So I think it is for this reason alone, because some of the most powerful people in the world who run some of the most powerful corporations in the world think this technology is going to revolutionize the world. It's important, I think, to be very carefully attentive to what they're saying about it. So just a few little stats. I mean, for some people may note, but Facebook, of course, when it came out, one of the fastest growing technologies ever to scale across the planet. It reached 1 million users in 10 months. And we saw when ChatGPT dropped, it reached 1 million users in 5 days. So we're really dealing with exponential times here, and we've never seen a technology like this before deployed at this kind of scale. Today, I mean, around 4 in 5 companies deem AI to be a top priority for their business strategy. If we look at here, this is a chart looking at AI use by organizations in the world. There's been quite a market increase from 2023 to 2024 across the world in adoption, and we fully expect to see from 2024 to 2025 a similar increase. And so, many companies are still, especially the larger enterprise companies, are struggling to deploy AI across their entire organizations. But almost all the prominent ones have currently deployed it in some regard and are actively trying to figure out how they can deploy it in order to basically to stay competitive in the future. But what's remarkable about this chart, I think, is that the growth is pretty consistent across the entire world. This is an interesting stat. I mean, 19 every 20 customer interactions will be AI assisted by 2025. And you think about that, and that would obviously by end of the year. That's actually quite remarkable to think, whether I'm calling the federal government about my taxes, or I'm calling to complain about a product being late, that there's an AI somewhere in that process that'll be basically interacting with us. So before I go on and start diving more into the specifics of AI, I thought it'd be helpful. OpenAI came up with this stages of artificial intelligence graph, levels 1 through 5, and I think it's helpful for a point of kind of orientation. So if we look at level 1, chatbots, so AIs with conversational language. I mean, all of us acknowledge certainly we're there. We've been there really since ChatGPT dropped in I think it was late 2022. Level 2, this is one that we've seen basically kind of scale more recently. So this is basically AIs which are capable of reasoning. And when I say reasoning, I say that in quotation marks, because what they're doing is it's not the same kind of thing that human beings are doing. But effectively, so this would be AIs which are capable of human level problem solving. And we really saw that kind of these kind of models, large reasoning models, really start peaking around the end of 2024, beginning of 2025. And then we get to level 3, which there's some debate about where we're at as far as agents goes, but certainly at 2025 is certainly been the era of AI agents. I would say very, very early agents. So these are agents, of course, being systems that can take actions, namely on our behalf, but also autonomously. I think most people would grant that yes, we started kind of the building AI agents and deploying them, but there's still a lot of work to be done here. So we expect this kind of level 3 agent phase to last probably several years before we'll start to see agents that can actually go out and actually take autonomous actions on our behalf for kind of longer horizon and more complicated tasks. Level 4 is an interesting one, innovators, so AI that can aid in invention. Many people would say that level 4 is another way of saying AGI, artificial general intelligence. And so, of course, artificial general intelligence is something that all the labs are trying to pursue. And these are AIs which are capable of basically human level would say, as I say, kind of critical thinking. They're able to contribute across multiple domains. So unlike narrow artificial intelligence, which is really capable of and can even meet or exceed human capability in a singular domain, artificial general intelligence would have the ability to effectively basically have human level capability in multiple domains and perhaps even exceeding human beings. So in this sense, they can certainly aid in invention. AGI is still considered to be several years away, as I'm sure that you've discussed. How many years away is a point of contention. Some have said it, like Elon said, 2027. We could be seeing AGI. Even says he thinks there's a chance with Grok 5, which is to be released, I think, in the next few months. They think there's a chance, at least it could be AGI. Others are saying it's more likely to be near the end of the decade or beyond. And then, of course, there's level 5 organizations. So these would be AIs which are capable basically of doing the work of an entire organization. Some would claim this is basically artificial superintelligence. Okay, so now that we kind of understand the landscape, let's just move on a little bit. And so I want to reflect a little bit on the rapid increase in capability of models recently. So I mentioned in the end of 2024, early 2025, we saw the introduction of reasoning models like O1 and then O3 from OpenAI. And you can see that with those reasoning models came massive improvements in capability across a number of different benchmarks. You're seeing down here, these are frontier math, and we have our ARC AGI, which is kind of our fluid intelligence, general intelligence benchmarks, coding, graduate level science questions, and mathematics. So these reasoning models, when I say reasoning models, these are models basically that can take time to really kind of think before the answer. So effectively, they can generate a chain of thought, they can activate tools, and they can use all this context that's gathered to think through the problem. So plan their answer, posit different solutions, pick the solution I think it's best before generating an answer. So this test time compute has been very effective at continuing what was thought to be potentially a slowdown in AI capability, basically due to the costs of scaling up pre-training. And talking about pre-training. So right now we're looking at, initially when we say the scaling laws, we're really referring to the pre-training scaling laws for artificial intelligence. And pre-training, of course, is that first phase of training the AI, the one that's very expensive and usually takes a very long period of time. These are sometimes called the base models. And so pre-training, the scaling law was basically the more compute and the more data you give a model, and effectively the more intelligent it becomes. But of course, these incremental improvements in capability that come about via pre-training are extremely expensive. So effectively, to get the next kind of step increase in intelligence, you have to basically increase compute by almost 10x. So if let's say a 1 gigawatt data center costs you around somewhere between 10 to 20 billion, if you want to see that the next step in capability, let's say going from a 9-year-old to a 13-year-old, that could be an example of a step intelligence increase. You essentially have to 10x compute. So you have to go from a 10 to $20 billion data center to a 100 to 200 billion data center. So because the compute costs for these pre-training scaling gains are so expensive, we've had to look for other ways to do it. And this is where kind of the post-training scaling comes in. This is kind of the reinforcement learning kind of paradigm, where essentially in certain very specific domains, we allow the AI, we give the AI basically an answer key, and it learns how to basically go about solving the problems on its own. And this is basically given rise to a new scaling law, this post-training scaling. And then we have the test time scaling, or the long thinking. This is where the reasoning models come in, or where they can actually they can pause it and think. They have more time to compute. The more time you give them to compute, to think effectively, the more likely they are to posit different solutions to a problem, and then effectively they can then pick the best one. And so this ability to kind of iterate in their thinking is also incredibly powerful. Okay, and we're starting to see this translate in very specific gains. And so if you take a look here, and these gains are across fairly large cross section of labs, predominantly based in the U.S. and China. So if you take a look here, we can look at the gains and intelligence. So that this benchmark is showing the raw intelligence of the models, basically since November of 2022. And you can see that the increases have been fairly steady. What's remarkable about this chart is it was thought for some time that it would be U.S. labs which would have a significant increase in capability when it comes to intelligence over, let's say, Chinese models. And this is large part because of the large concentration of AI researchers and compute and capital. But you can see here that several of the labs that are ranking up here in the very tops, labs like DeepSeek, which we've all heard about, but also Moonshot, which is a new one, is incredible. So these open source labs are now actually ranking up there with the very top labs that we have, like Anthropic, like Google, and like OpenAI. All right, so moving on, and if we take a look again, just to reiterate, these are basically represent the best models in the world, so the ones that essentially rank the highest in intelligence. And we can see, OpenAI, of course, the GPT-5 is still sitting right there at the top, but Kimi K2 from Moonshot, which is a Chinese lab, right there. This is an open source model, open weights, and you can see it's right below ChatGPT, which is astonishing. Of course, then we have Elon Musk's xAI Grok 4. He's in the process of training Grok 5. We expect there to be a big step increase in intelligence with that release. And of course, then we have Anthropic and so on and so on. You see Gemini 2.5 Pro, when it came out, it was certainly frontier. It's now fallen a little bit behind, but we're expecting an imminent release of Gemini 3.0, and they should shoot back up. So just to say this is incredibly competitive. And as you can see here, the actual difference in reasoning intelligence capability between the Chinese labs and the American labs has effectively been closed. Another thing I just want to point out here, I talked about, you have the difference between we have large kind of reasoning models, and then we have large language models. Large language models being the typical kind of pre-trained with kind of limited post-training with human feedback. And you can see that the purple models represent reasoning models and the blue represent non-reasoning models. So you can see how the reasoning paradigms, giving models time to think, has basically resulted in an entire pivot of the industry towards these models as a way of achieving greater and greater capability. Another thing that's been remarkable is the increasing context window in the models as well. So this is also very important because think of context window kind of like a short-term memory for models. Obviously, the more short-term memory that they have, the more they can take into context. So instead of it just being, let's say, a small essay, now they can take, almost like Encyclopedia Britannica into context when you're asking it questions. This obviously has a lot of very specific practical applications. And so Google was one of the first to deploy a million context window. And now we're seeing even with Grok 4 Fast, which was recently released by Elon Musk, they have a 2 million context window. So as these context windows get bigger, they're going to be capable of basically being more and more useful to us, especially as agents, as they're able to kind of take in more and more context about our lives when they're actually basically operating on our behalf. So these gains in intelligence are making it very hard to actually benchmark these models. In some ways, they're demonstrating greater than human capability in certain areas. So how do we test these models? So this was a question at Scale AI, which worked at the Center for AI Safety to come up with a kind of a new benchmark series called Humanity's Last Exam. Quite provocative. And effectively, what they did is they went to basic Pulitzer level academics. So these are the best of the best, best and smartest people we have in the world to put together a bunch of new problem sets. And effectively, this became one of the most important benchmarks for determining where AI is at as related to the most intelligent people on Earth. What's been remarkable to see is some people have thought it could be a decade before we'd see meaningful progress on Humanity's Last Exam, but that's not turning out to be the case. This graph is a little bit kind of complicated to wrap our heads around. But if you take a look here, you can see that basically we have the release date and we have the score on release date in the bottom. We have score on the left. What's important to note here is, as you'd expect, GPT-5 is right up there. So is Grok 4. And then we have the open source, Kimi K2 models. But you can see here that these models are now getting 26%. I mean, that is quite remarkable that this model in a very short period of time is basically been able to solve 28% of the hardest problems that humanity can come up with. So all you have to really kind of do is to take a look at that trend line, and within a year, we expect them to be close, maybe potentially up to like 80% on this benchmark, which again, remarkable progress. Another important benchmark to pay attention to is the ARC AGI. Now, this ARC AGI is testing for something called fluid intelligence. So I talked about the difference between artificial narrow intelligence and artificial general intelligence. It's thought that an artificial general intelligence would have to possess strong fluid intelligence, which is effectively what makes human beings makes our intelligence so potent. Is the fact we're able to kind of distill and apply our intelligence efficiently to new problems based upon past experience. And this is something that models have always struggled with, namely because they've been effectively trained in large part to memorize, and then basically if they see something, they basically go and recall the information from their parameters and they spit out an answer. But effectively what we need to see in models, if they are to really be capable of fluid intelligence, is more system two thinking. So system one being kind of like what would be if you were to make the distinction between system one, system two, and human beings, system one would be you ask me a question and I just know the answer. I basically have it memorized and I just quickly blurt an answer. Another example of system one thinking would be if I'm driving a car and I'm actually thinking about my day at work and what I'm going to do when I get home in the garage I need to fix up while at the same time I'm driving. That would be an example of system one thinking, whereas system two would be when I'm totally focused on a problem. It's hard and takes all of my focus and attention. And so effectively what we're trying to bring to these models is that system two level thinking, the ability to kind of efficiently operationalize previous experience and again apply that intelligence to new problems. And this is something, again, models have suffered because effectively we've had a hard time getting them to kind of move beyond memorization to actually to generalize what they've learned. But you can see here with ARC AGI 2, the first benchmark for AGI has effectively almost been saturated. So now we're on ARC AGI 2, and with Grok 4, we've seen a couple of individual scientists, E. Pang and Jay Berman, have actually used Grok 4 and fine-tuned it to get up to almost 30%, which is quite remarkable. So again, if we play this out in a year to year and a half, it's quite possible we may have actually saturated this benchmark, which effectively would mean that the AIs are actually demonstrating fluid intelligence, which is something that's been very kind of unique to humans and animals. What's also been remarkable is as we see the increases in intelligence for these models, we're also seeing that the actual price of service in them has been steadily decreasing, which is again to be expected. The more compute that these models need, that of course means that industry has to create more capacity. As they create more capacity, that in principle should bring down the price. But it's been quite a dramatic drop, and of course there's something called Jevons paradox, which basically dictates as something becomes cheaper, the demand for it increases. And that's effectively what we're seeing. Once upon a time, servicing AI models and running inference with them was very expensive, which means very few people could actually afford to actually use this artificial intelligence. But now, as the cost of serving it is going down, more people are saying, "Oh, okay, it's not that expensive, or maybe I will use it." And this is actually increasing demand. And of course, as this increases demand for AI and this increased compute capacity increases, and we're seeing it's pretty steady algorithmic gains in the models. There's an important paper that came out called Situational Awareness by Leopold Aschenbrenner. It was an important AI research at OpenAI, but it's since left. And he talked about the intelligence explosion. Effectively, this is really when we see models which are capable of something called FARSI or fully autonomous recursive self-improvement. So effectively, the models are able to kind of learn on their own, and as they learn, they basically update their weights, and they're becoming increasingly intelligent. And so when the AIs are capable of doing this, we expect to see this intelligence explosion. And effectively, what this means is you could in principle have a self-learning AI. Let's just call it an AGI. Which could be, possibly as small as a 1 billion parameter model, and then we can of course copy that model millions of times. And effectively, we would have millions and millions and millions of AGIs, millions of intelligent AI systems, and you can imagine how that would affect the world economy. And of course, so this is very exciting. This video is now quite old, but this is an example of this is Sal Khan. He was the founder of Khan Academy, one of the most important online education platforms, particularly in places like India, for people that have difficulty getting access to high quality kind of educators. This is an example of him with his son, where ChatGPT is actually tutoring his son on a geometry program. So the AI is effectively able to see the screen, is able to see the son, interact with him through voice. And so of course, with these AI gains, there's all these really exciting possibilities for education, where effectively you can have an AI which can adapt itself pedagogically for each student right? So it understands that they're a unique pathway, the most beneficial ways for that a human being could learn, and it will adapt its pedagogical approach to help them succeed. And so this has, will have enormous, I think, implications for education. And I think also for skills training. So, and definitely there's a lot of exciting possibilities for this technology, of course, when it's directed to important and obvious problems. And then, of course, we have robots. This is something that when we talk about AI, I think many of us think about these disembodied AIs, which live in these large compute clusters, and we think about typical white collar work, things like law firms and doctors' offices and things like that. But it's important to remember robots or embodied AI. Because as much as it is pretty much acknowledged at this point that AI will be coming for basically almost all office jobs, we have to acknowledge the fact that it won't be long before robots will be coming for a lot of blue collar jobs. And of course, this is obviously going to be a bit of a challenge. And right now, there's still a lot of technical issues that are being resolved with robots. For those of you interested, you can look up Morvox paradox. But effectively, a lot of the tasks that we consider to be simple, things like loading the dishwasher or doing the laundry, are actually effectively very difficult for robots. So in order to have an effective robot which is able to operate in the world, it needs to have a pretty strong world model, which is effectively very difficult to train. So there's still some pretty important technical bottlenecks that are preventing the production of these robots at scale. One is just a manufacturing bottleneck. One is actually a kind of an AI bottleneck. But everyone expects for the next couple of years, we're probably going to crack that. At least we'll crack the AI problem sufficiently that we think the AI will be generalized enough to be useful at home. And the manufacturing scale issue is expected to be solved in somewhere between 2 to 4 years. And of course, when these robots start entering into the factories and they start displacing workers, it's highly likely that workers are going to become aware and see what the writings on the wall. And there's a real possibility that they may react very negatively to this, seeing that their jobs, now all their jobs, are effectively at risk. And so I think it's important when we think about AI that we think very specifically about robots, which we track their progress when we think about the implications of them being scaled, that they're being manufactured at scale. So just to talk about job displacement, this is a chart from Indeed, which is one of the biggest job posting boards in the world. You can see from 2022, which there was insane demand for software engineers. You can see that the drop has been quite remarkable, which is why many students which are studying computer science are finding it increasingly unlikely that they're going to get the job that they want. And so of course, given the nature of computer programming, it is one of those fields that it's kind of it's perfectly made for artificial intelligence, in the sense that computing problems it's very easy to kind of come up with singular tests for them that effectively we can test AIs on to see if they're effectively growing and improving. We call it it's kind of a verifiable domain. But as the AIs become more increasingly general intelligent, they'll start moving beyond, like, say, the STEM fields into other fields. And I expect you're going to continue to see declines in demand for hiring people, respectively, to what we're seeing here. Recently, Anthropic and OpenAI released some statistics on how people are currently using models right now. I thought this is a pretty interesting chart. I don't know if many of these will really surprise us that much. One thing that is worth noting is that I think there's a lot of people, there's a lot of hype around that AI people are using AIs as kind of life coaches, and they're developing these kind of personal relationships. And most certainly, I don't want to dismiss the fact that's not happening. There's been some tragic stories I think we're all probably aware of. But to say, for the most part, based on the data that they're sharing with us, it doesn't seem like that's a very popular use case yet. So you can see relationships and personal reflection represent just around 2%. The vast majority of queries are, editing or critiquing provided text, asking questions about like specific information, trying to retrieve specific information about a topic, how-to advice, health and fitness and self-care, and of course tutoring and teaching. So pretty standard. So I think it's important for us. I think obviously we should be very careful to protect minors who are more vulnerable and are more likely to anthropomorphize these technologies. But effectively, right now, what we're seeing is, for the most part, people are kind of using them as kind of a useful augment. In many ways, they're using AIs in the same way they were using Google before AIs existed. One thing I think it's important to note that is that as these AIs get more and more intelligent, we're finding it actually more difficult to actually change their values, which is interesting. Now, in some ways, I think this could be interpreted as a good thing. I think we'd all like to believe that there is a kind of a common human meta ethic that exists out there, and as the models get access to more and more high quality training data set, they're just basically doing the math and kind of drawing conclusions. That there is kind of a common ethic or values that it should be kind of steered by. But this is also becoming a bit of an issue at the same time, because, for instance, if we're talking about AI alignment, particularly, let's say in the Catholic market, if I'm trying to align a frontier model specifically to the Catholic faith, and it's been trained and it has developed this kind of meta ethic, there could be situations in which those two conflict. And so, yeah, you may be able to, to post-train the model to effectively work in, let's say 99% of occasions. But there is that possibility, because there's this other meta ethic in the background, that there may be times where it doesn't effectively work, right? And so this is something that we have to keep a very close eye on. We generally have noticed that as the models become increasingly intelligent, they are better in following instructions. But this particular area could be a problem for alignment, which is why I think it's worthy of our attention. I just throw this out here. I mean, this stat is from 2023, but I think it is important to note that it's a bit disturbing how many leading AI engineers actually think that there's a chance that AI will actually end up destroying humanity. I don't think that we should dismiss those concerns. I personally am not worried about the technology per se destroying humanity in so much as I am about people ripping apart civilization in response to the technology. But when people like Elon Musk, claim there's roughly a 20% chance, Jeffrey Hinton, the godfather of artificial intelligence, says, somewhere between 20-25% chance this technology could destroy us. That obviously is insane and seemingly unacceptable, and begs the question: if in any other market, in any other context, when would we ever consider adopting a technology that has a 25% chance of wiping us out? I mean, we just wouldn't, right? So how is it we've arrived here, and why haven't we stopped this train? Stop this train on the tracks. And effectively, I would argue this is predominantly the reason, and I think this is kind of widely known and accepted at this point. Is we're in a competition with China. At this point, I think it's fair to say that American and Chinese AI labs are basically at parity. The only difference would be compute. NVIDIA still has a technical advantage there, but that's not when all's said and done, that it really doesn't amount to a whole lot. And so this race is intense, and I do feel, considering how important AGI will be when it's finally achieved, it'll affect, almost every domain of human life. It'll have massive economic implications, and so I don't think either of these countries can take their foot off the pedal, and I don't think that they will. So at this point, I think the idea of a pause or slowing down the technology is effectively over. We've tried twice and failed, and given the stakes, I think it'd be really, really hard to convince either one of these superpowers to stop. So I think we just have to acknowledge the fact that these technologies are going to continue to be developed, and then we have to figure out how we can ensure the technologies in the process of developing them don't end up wrecking civilization. All right, so when I talk about China and the U.S., I think it's important to note the real possibility that China may actually win this AI war. I say war or in quotation marks, and there's a few important reasons to be aware of. One is China's capacity to build energy far exceeds anyone else's in the world. You can take a look here. Basically, what we're seeing here is electricity consumption, and of course, consumption is then matched with capacity. China has become exceptional at building energy capacity, and this is a big problem because without energy, you can't run massive data centers, which are used for training models and also for inference compute. So if we can't solve the energy bottlenecks, that means we'll be at a significant disadvantage in this AI race. And given the complexity of building energy capacity, particularly in places like the States and the European Union, most people are pretty pessimistic about the chances we're going to do this. So it is going to take some kind of Marshall Plan, some kind of unique strategic focus of the countries in order to build up this capacity. Now, I want to note something else as well. I mentioned to you that China and the U.S. basically are at parity when it comes to kind of AI technology, which is remarkable because when you look at the global private investment in generative AI, United States, as you can see, is far, far more investment in this technology. Now, for some of us that may be obvious. We're dumping tons of money into the U.S. labs. they're innovating, and then people claim that China's just stealing the insight, the science, and they're using it to improve their own models. And certainly that's true to some certain extent, but that's not entirely fair. The Chinese have also contributed very important, significant research updates. So I think this is important to note. China has effectively been able to kind of bootstrap AI using inferior technology, and they've been able to get to almost basically parity in capability, despite this enormous investment difference. Something else to note here as well, if we look at availability of computer science education by country, and this is, I guess, at 2024, this is also remarkable, right? So if we look at the blue, this is effectively where computer science education is obviously an obvious priority of the country. Interesting that you have, China is up there. It's an elective course. And now if we look at the purple areas, unfortunately that's us in North America, and at least half the West over there. We're well behind. And so when we look at just the number of AI people, basic computer literate individuals, and those who have the potential to move into kind of AI research positions, China has a significant advantage. If for no other reason, there's just more people who have a broad spectrum exposure to AI. And of course, like I said, winning the AI race is more than just training talented AI researchers. It's also engineers who are specialized in building out energy capacity at scale, are able to manufacture and compute at scale. And so if you have a robust CS education, robust engineering schools, that's going to basically position you well in order to win this race. And I've talked about this already. I just want to note it. This is frontier language model intelligence by country, and again you can see that China and the U.S. are basically at parity. And you can see that China obviously was significantly behind, as of 2023, but they've been able to make these kind of significant step increases to achieve parity. Again, we look over here. This is open source models, and this is something that the U.S. has really fallen behind on, which is to some extent quite disturbing. The last really successful open source model to be trained in the U.S. is OSS by OpenAI, and you can see that demarcated here in basically August of 2025. But really the leaders in open source now are China, and every time they release a state-of-the-art model, which basically almost achieves parity with our best models and releases out into the open source, all that value that's been effectively been created by the American companies, achieving their state-of-the-art models is basically kind of wiped out, which is quite remarkable. And I mentioned before that some people say, that they're just stealing research from the U.S. and they're just applying it. I mean, that's not entirely true. Like I said, Spiking Brain 1.0 was quite remarkable, where they've claimed that they built like an AI which is modeled off the human brain, which is 100 times faster than rivals. And this is of course important because their chips may be slower and maybe more energy hungry, but they have the capacity to manufacture a lot more chips, and they have the power to actually run them. So when they start making efficiency gains on chips, that becomes that's very much we have to note that, because effectively that may mean that they have more efficient chips, and they have greater energy capacity, and they have more manufacturing capacity. And effectively, it doesn't really matter if you have an AGI if you don't have the compute to actually run it. This is why it's so important that we have the infrastructure in place, because the country that has an AGI and effectively has massive amounts of compute and power to power will find significant advantages in this race. And of course, Elon Musk, a famous quote from him, "In a benign scenario, probably none of us will have jobs." And I think it's important to kind of, to reflect on this. But before I do, I just want to reflect a little bit on kind of the boomer and doomer paradigm. So Max Tegmark, who's is a great scientist from MIT, is a very notable person in the AI community. I think many people would say that he skews doomer in the sense that these technologies, the way that we're going about building them, and the way that it seems like we're going to be kind of integrating them into every dimension of our life. Given that we're having a hard time, we don't effectively understand how these models work. Effectively, we know how to grow them, as Anthropic says, but we don't know how to effectively build them. Is quite remarkable. It's a whole field called mechanistic interpretability, where we're trying to understand these models that we're training, but they're so effectively complex that we haven't been able to make a whole lot of progress in that area. So effectively, we're training models, we're unleashing them in the world, we're hooking them up to key systems, and they're performing more and more agentic actions, and we don't really understand how they work, and we can't effectively we can't know for sure if they're aligned. And he thinks this is a recipe for disaster. Jan LeCun, on the other hand, who was Meta's chief AI scientist, he's just recently departed. One of the most notable AI researchers in the world, helped pioneer convolutional neural networks. He says this is ridiculous. He says like AGI is not going to be an event. Like we're not going to have like a Terminator scenario where all of a sudden AGI just awakes and surprises us. He thinks AGI will be developed by components that will be developed by all kinds of different labs all over the world, and there'll be kind of a pretty open collaboration. And because this will be kind of an open process, which will be done, I wouldn't say so much necessarily in the open, but there'll be a lot of open source contributions to it. He feels that there'll be time and there'll be ways to mitigate AGI. And so the risk of AI destroying us all, meaning the technology itself destroying us all, he thinks is effectively very low. Although he does recognize the importance of regulation and ensuring that the technology is released in a disciplined way. Elon Musk, I said before, I think there's a 20% chance AI may destroy the world, but I mean, he felt so strongly about this. Is one of the reasons why he decided to build XAI, his AI company, which he's done exceptionally efficiently. To the point where he's built one of the largest compute clusters in the world and is now basically built one of the best models in the world. And everyone expects Grok 5, the model that's currently just being trained, to be probably the best in the world when it comes out. So one of the interesting things about his training approach is he's focusing on two training objectives. One is truthfulness, so making sure that everything the AI says is grounded. And then two is curiosity. And he feels that training curiosity is very important for AI, if for no other reason that the AI won't kill us because it's curious. It wants to see what will happen with human beings. In the same way, we love to observe animals and to see what they do because there's some kind of fascination with that. He feels that AI may have, it's important we train into it a similar kind of fascination, so that it's not competitive and feels that we're some kind of threat or risk. And then of course, there's Father Philip Larrey, one of the most notable emerging tech kind of philosophers and theologians. The Catholic Church, I think he would be somewhere along the same wavelength as Elon. He thinks there's a chance the technology could destroy us, but it's more likely that humans using the technology will destroy us. He thinks this is why it's so critically important that we understand what human flourishing is at an individual and a civilizational level, and that we're directing the technology to solving the problems which are impeding human flourishing. So effectively what we want to do, instead of just racing to build greater and greater capability, we should be looking at the problems that we need to solve in order for people to flourish. And we should be directing the technology more in those areas. And he thinks that might be a way of ensuring that the technology doesn't run off the rails. I just want to note that right now with Pope Leo, there's a lot of there's a lot of people who are celebrating the fact that he's acknowledged AI is going to be an important critical focus area of his papacy. But I want to just acknowledge the critical role that Pope Francis had in getting this started. I think in many ways he was very quick to acknowledge the importance of the technology and react. This is him at a meeting of the G7 leaders. What was interesting about this meeting is that he was given the opportunity to speak to one topic to the G7. He chose artificial intelligence. The speech was actually, I think, quite remarkable. So again, I think it's really says a lot that the church has recognized that this technology is going to have an important impact on the future of humanity. It's already starting to wrestle with what that means. And I think what we have to do as the laity is ensure that we're working hand in glove with them, trying to bring our own unique gifts and abilities and vocations to bear, so we can support the Holy See as they think through these very difficult issues. All right, so just very quickly, Catholics versus transhumanists. I think this is going to be one of the most important, I won't say conflicts, but I think there is certainly going to be conflict. But I think these are two competing visions, which I think we have to focus on. So I'm just going to focus on two individuals here. I'm not saying Demis Hassabis to the left is Catholic. He's not. But what I will say is that there's amongst the AI community, there's a very strong transhumanist bend, which I think many of you watching this will have already intuited or know for certainty. But just to give you an example, this is Alexander Wang, who heads up Meta's artificial intelligence, superintelligence division. So basically, he's kind of the chief AI czar for Meta. Meta, of course, the company that owns Facebook and Instagram. So their reach is absolutely enormous. He was recently on a podcast with a podcaster named Sean Ryan. And being a young man, Sean Ryan asked him, when is he planning to start a family? And Alexander said to him, well, he'd like to wait on that because he's waiting for further developments in Neuralink. And so I found that quite quite striking. We've known for some time that there's strong transhumanist vibes within many of the heads of these big tech companies. I've never heard one speak so directly to this issue of transhumanism like that. I mean, so effectively, what Alexander is saying here is that he believes his child should be basically merged with machine. And I think that he probably thinks that's a good thing. Expand the child's computational capabilities, so it could make presumably a greater contribution to the common good. But of course, we as Catholics would see that as not good and very much a danger. So I think it's important for us to acknowledge that this vision of transhumanism, effectively that we have to merge with machines in order for humanity to move forward. Many would say that Mars colonization is not going to be possible without some kind of man and human merger. And so anyone who are solely fixated on that, like being like the next core objective for humanity, is to ensure that humanity is multiplanetary and we colonize Mars, there's a real risk that transhumanism will kind of be the price of admission in order to realize that vision. And I think we as a church have to come to grips with this. Demis Hasmus, again, head of the lab, he's also on the Pontifical Accounting Sciences, as many of you know. I've never heard Demis say anything along those lines. He's primarily focused on applying the technology to solve things like disease, so real human problems. And so I don't want to paint that everyone in the AI feels the same way as Alexander, that merging with machines is inevitable and a good thing. But I think we as Catholics have to be clear about why that's not good. Right. One of the best people I've heard speak to this very eloquently is Father Alejandro Crosswaith from the Angelicum, and basically what he'd said to me when we posed this kind of AI robot, it's an AI kind of android, kind of transhumanist. He kind of responded to these issues by saying, well, if the technology is intended to restore our full humanity or help us realize our full humanity, it's a good thing. If it's impeding, or it's looking to augment, then it's a bad thing. And the example he used is someone were to lose their limb in a car accident, and we were to give them a robotic limb. This is a good thing. We're restoring their humanity. If they're getting a machine implanted in their brain to expand their computational capability, that's not restoring their full humanity. That's augmenting their human their computational capability. And the question is, for what purpose are they doing this, right? And I think that purpose is critically important for us to understand that what is the telos of man, what is the telos of civilization. So we can kind of point out that some of these mergers that are being suggested are effectively just not directed towards human flourishing, at least from a Catholic point of view. All right, I'm just going to finish off my talk to speaking a little bit about Catholic AI. And so we recently just had something called the Builders AI Forum in Rome. I believe it was last week. We had it, and we were bringing together basically kind of technologists and ethicists and philosophers and people from industry and investors to talk about AI. We had our first forum was in October of 2024, and that was just kind of the level set. This one was more bring people together in workshops to work intensely through the issue of how do we, what is the current state of AI as it relates to a particular domain, and how do we effectively ensure that the technology is being applied in order to find some kind of competitive advantage. And so the areas we were looking at were AI in healthcare, AI in education, AI in robotics, Catholic AI in the media. And we had another group looking at consciousness and the idea of possibly creating a kind of a new Turing test to test for it. This is, I think, a very important research area in the church. These machines, as they become more and more capable, people are going to say that they're alive, that they're conscious. And the church has to effectively have an answer to whether they are or they are not. I expect people will eventually want to marry these things, especially when these AIs become embodied and look very much like us. And when people go and perhaps get they get civil recognition for their union, of course they're going to come to the church and want to see that marriage convalidated. Of course, I expect the church's answer to be no, but we have to provide them a better reason other than just no, right? We have to explain to them why. And I think for the first step in that is defining what consciousness is from a Catholic perspective, at least getting clear about what constitutes consciousness. And then hopefully once we have a better understanding of what it is, we can develop better testing methodologies, which is going to be important for us as a church, but actually it's going to be very important even for the secular AI research community, as they're all struggling with these issues. And right now it's difficult for the church to engage on this, namely because we don't have a kind of a singular understanding of this. There's, depending on who you talk to, they have a different understanding of consciousness. So this, I think, is an important research area, and this is one of the more, I would say, lively conversations we had at the forum. So for us as a company at Longbeard, we recognize that if we're gonna do Catholic AI, unfortunately, we have to intervene at three of the four areas of the pyramid of AI, and that's effectively at the data layer. This is why we built our product Vulgate, which I'll talk about in a moment. Effectively, we need to grow the Catholic data set. You can't train good models without lots of high quality data. We have most of which has been digitized, but we need more. And so we needed a way to grow that data set. Then, of course, there's the algorithms, which is effectively the ambition is to kind of train our own AI model, which we've effectively trained the world's first Catholic language model called Ephraim. We're preparing for our third training run. But we feel that training a model with an objective function, as we say in the industry, with a clear objective of fidelity. So fidelities and fidelity to the magisterium is critically important. A lot of the models that are all the models that are trained today are effectively trained on multiple value systems, and alignment is whatever they're always trying to discern what the user's value system is, what they believe in as much as they can. They're always trying to align their answers to the user. So, of course, when you're building a model which is effectively needs to be able to align with 6, 7, 8 billion people, then trying to get it to be fundamentally aligned to the Catholic Church is effectively impossible. And this is something that we found so far in trying to achieve alignment through post-training existing models. It just doesn't hold up over what we call a long tail. It may be right 9 times out of 10, but that 1 out of 10, it just gets it wrong. And that's large part because there's just so much signal inside of the model. So sometimes it can get confusing. So we think training a Catholic model is critical to this process. And of course, then there's the application layer. So like ChatGPT, we built our own called Magisterium AI. And so speaking of Magisterium AI, by the grace of God, is the number one answer engine for the Catholic Church in the world. It's used in 165 countries and over 50 languages. We still have a lot of work to do on this, but we're happy with the progress. I won't get into all the details of what it's taken to build this, but it's been an enormous hill climb to do it. There's been a number of challenges throughout the way. The importance of expanding the knowledge base to give it access, to more and more church knowledge, so it has more and more context when answering questions. The problems of generalization when someone's asking a question, posing a particular moral scenario, and the AI has to apply church teaching from first principles to the situation. There was innumerable challenges, and many of these challenges we haven't entirely resolved. But we found that a combination of ensuring that the model, that everything it says is grounded in source documents, has been along with having other scaffolding like prompt templates and giving it access to specialized tooling to understand unique facets of the church. These things working together in an orchestration layer, we feel been able to mitigate hallucinations for the most part, not entirely, but we're making good progress. But ultimately, this kind of compounding AI system we built, we're hoping that by using a fully trained, a Catholic model, this will help us to achieving greater heights in the area of fidelity. So a lot more work to do here, but we're making good progress. I should also note as well that, in addition to building, the mission of the company is building and scaling Catholic AI. Part of that mission is scaling Catholic AI, and so we recognize that the work we've had to do has been very technically complicated. It's cost a lot of money, and effectively, if we want Catholic AI to scale, we can't expect everyone to basically climb the same hill we have. It would be effectively almost impossible. So one of the reasons why we built an API is to allow others to build on top of what we built. So as we digitize more and more knowledge, as we build new tools and new strategies to kind of mitigate hallucinations, to make sure that the AI is more grounded and faithful, we can then share those with anyone who wants to build on top of us. And so effectively, this creates a rising tide. So this is one of the primary missions of the company, is to ensure that anybody who wants to build on top of faithful Catholic AI can do so. So I mentioned Vulgate. So just a very, very briefly, this platform was initially was suggested to us, creating by the rector of the Pontifical Oriental Institute in Rome. They have the rarest library for the Eastern churches. And so their constituency is the Middle East, East Africa, Eastern Europe, India. And so it's very difficult for a lot of these researchers to come to Rome to pull books out of the stacks. Obviously, it required getting on a plane. And so, Pope Francis had spoken, a lot about reaching the periphery. And so Father David Nazar responded to that call and came to us and said, we'd like to find a way to digitize our library and make it accessible to anyone in the world on any device in their native language. And so that's where the project Vulgate began. So effectively today, again, it's humbling to say, I think Vulgate is probably the most advanced AI library platform in the world. It was built to help scale digitization. So effectively, when you upload scan images into Vulgate, it can actually extract the information, but it processes it and cleans the data, keeps the structure, so the headers and footnotes and everything intact, and then converts it into vector embeddings, which effectively means that anyone in their native language can query documents in really effectively any conventional language, whether it be Greek, Syriac, whatever else, which is quite remarkable. So it's a powerful tool for universalizing access to knowledge. Effectively, Vulgate is designed to help institutions share access to each other's holdings, and anything outside of copyright, we effectively make available through Magisterium AI to anyone in the world to query. So I talked about our API. And then, of course, there's the Alexandria Digitization Hub in Rome, which we stood up. This is where we do the physical ingest, and we are using a kind of a fleet of robot scanners to help facilitate digitization of the books at scale. Of course, once the robots have finished scanning the work, it then goes into Vulgate for processing. And you can see this is basically an example of the Alexandria hub at work. So we have some manual scanners, some more precious kind of manuscripts, and we have the robo scanners with their robo arms, which are kind of automatically turning pages and scanning things for us. Not sure if this will actually play, but it'll just give you kind of a sense of what robot scanners are capable of. You can see, so effectively, once a job is done, the robot arm comes down, grabs the page, turns the page, and so on and so on. So this is how we're planning to go about effectively digitizing the Pontifical University libraries in Rome and expanding that Catholic data set. And I talked about Ephraim, the world's first Catholic language model. This is an important program within Longbeard. And so a lot of the labs right now, they're chasing artificial general intelligence and they're chasing artificial superintelligence, which I think is important. But and angiocarpathy is focused on this. But in many ways, those cracking those problems will be important. But really, what we're looking at now is more and more. So how can AI kind of be like an operating system, which effectively, kind of like how computers were, they allowed us to access the internet and access our files and write. Effectively, what we're doing is we're kind of putting the LLM to kind of replace the computer, and effectively, it can then effectively perform actions for us. So it becomes a mode of interaction, but it's also a mode of agency. And so this paradigm is something that we've thought a lot about. And so right now what we're seeing is the AI companies, you kind of have the Google and Anthropic are focused very much on B2B, whereas you have the labs like OpenAI, Meta, and XAI seem to be focused a lot more on B2C. But there's a challenge with these labs, and in large part there's a challenge of trust. So we think of OpenAI recently. He was just asked if the government were to come and ask for user data, would you have to hand it over? And OpenAI said yes, we would. So if an AI agent effectively is going to be useful to me, I need to give it basically unlimited context to my life. I have to give it kind of all the keys. It has to know basically everything about me. But and that means effectively it's going to have a lot of data on me. And if I know that data is living on a cloud controlled by OpenAI, and the government can come and take that whenever they want, a lot of people are going to be very reticent to provide that level of trust to the AIs. And we think that in many ways this will actually slow down the likelihood for full agentic use of AIs. And so what we looked at this problem and said, really what we need here is kind of a Catholic approach to this, which is focused on subsidiarity and sovereignty. And we think that this, and effectively going back to like the use case, for those of you who've seen the movie Iron Man, he has this AI Jarvis, which effectively is kind of always with him. And he can always access it. And Jarvis is basically always monitoring what he's doing. And if that effectively is what it's going to take to build kind of the agent of the future, then trusting that AI is going to be absolutely critical. And this is one of the reasons why we're focused on building Ephraim. Effectively, the idea is that we can provide an AI which is aligned to the Catholic faith, but can run on compute at home. It stores the data at home, and so in some way, in this way, it's sovereign in the sense that it's at home. And it's protected more by property rights and things like that. It's harder for people to be able to come and get access to your model or the data because it's living at your premises. And so in this way, you can be a bit more confident and trust the AI. It's aligned to the Catholic faith, and where it runs and where the data is stored. And then effectively, the AI would then enable you to do all the things that you'd expect. You control robots, operate identically at home within your smart home, to travel with you on your phone. We feel that this is ultimately the product that's going to be necessary if we're really going to serve users into the future. And of course, if we're going to do this, and I think that one of the unique things about this whole project is recognizing that the Catholic Church might be the only organization in the earth which can truly ship aligned AI. And that's because in order to train aligned AI, you need effectively a lot of data. You need really solid evals to effectively to test and make sure that the AI is being faithful to the data you're providing it. And because the Catholic Church has been around for 2,000 years, and because our doctrine has been fundamentally consistent for all those years, it's kind of made for AI. And because we as Catholics align ourselves to kind of one theological and moral and value system, it makes it easier to train an AI like this. And so I think in many ways we can actually ship this faster and ship a product more reliably than anybody else. And this may be a way to help others effectively how to learn how to do this. Okay, so what's next? So we're working more on enhanced reasoning, doing things like deep research in the realm of Catholic AI, increased personalization so that AIs understand where users at, where effectively they want to go, effectively to be a saint, and then how do we help facilitate them going there? This also points to the problem of off-ramping. We recognize that the AI is not meant to be an end in itself. People shouldn't be sufficient. It shouldn't be sufficient, and they shouldn't be satisfied using our AI. We should always be looking for opportunities to connect them to community and effectively to a parish, to a priest and to a spiritual director. So this is one of the unique things about training our AIs. We want to train it to understand ultimately what a person needs in order to be a saint, which is effectively others and God's help. And so we need to always be ensuring that they're being connected to other human beings and are very embedded in a local Catholic community. Voice UIs is something we just recently launched, so you can actually interact with Magisterium AI in voice, more advanced tooling, enriching our API so we can effectively help others who are trying to build Catholic AI, increasingly building more and more complicated agents, training embedding models, a Catholic embedding model. This is the process, embeddings being the process of converting plain text into mathematical semantic representations of the meaning. There's a lot of kind of ancient languages and things like that the current embedding models don't necessarily capture. So working with theologians here in Rome, we hope we can train a unique embedding model for the Catholic faith, and that'll make our AI more faithful. Coming up with a public Catholic benchmark. This will be a way to benchmark how secular AIs do on core doctrine and dogma. We think this could be important, and this means benchmarking them, but also providing the data required for the labs to effectively to train, so they can actually ensure their models are better at scoring highly in these benchmarks. So this is just a way to benefit kind of everybody. Working increasingly towards building sovereign AI and trying to build increasing autonomy in robotic digitization, so we can scan more books more quickly and get more data to people around the world. For those of you who are interested in learning more about AI, I recommend the IBM Technology Channel. Matthew Berman is a great influencer. Artificial analysis is great if you're looking for analytics. Many of the charts I showed in this presentation are from artificial analysis, and the rundown is a good newsletter to follow if you want to keep up to date daily on AI updates. So overall, I'm very bullish on Catholic AI. I think it's going to be critically important for humanity, for the future of civilization. Not to get a chance to get into it too much, but I truly do believe that it's the church which should be kind of leading the effort to help define what individual flourishing is, what collective civilizational flourishing is, and then helping to ensure that we're pointing these really powerful technologies at problems that really matter, and will ultimately help ensure that all human beings win. So thank you very much for the opportunity to speak, and I look forward to hearing from you.